Welcome to Science Tutor. In this video, we shall be discussing endothermic and exothermic reaction by considering the question on the board. And it says we should draw and label an energy profile diagram of an endothermic reaction showing activation energy, heat change, delta H, and then activated complex. As an introduction, what is an endothermic and exothermic reaction? An endothermic reaction is a reaction in which heat is absorbed from the surrounding. That is endo. Heat is absorbed from the surrounding. While exothermic reaction is a reaction in which heat is liberated to the surrounding, or I can say heat is given off to the surrounding. That means heat is lost to the surrounding. So there are two different terms we need to consider. One is absorbed, another is liberated, given off. Now, for the purpose of this question, we shall still come back. I'm going to take my time to explain both reactions, citing series of examples. But for the purpose of this question, this section, we shall be considering the question. Now, for an endothermic reaction, it simply means the heat content. The heat content, delta H. Delta H, in previous videos I explained these terms, the heat content. The heat content is also called the enthalpy. So the heat content, which is delta H, is always a positive value. The positive heat content. Delta H is always positive for an endothermic reaction. Delta H is negative for an exothermic reaction. Now, knowing that delta H is positive for endothermic reaction, what this simply means is that if I'm to draw the energy profile diagram, it's going to take this shape. I have my heat against temperature. My heat energy as heat in kilojoule per mole against reaction pathway. Let's use a temperature in this case. Okay, now drawing the energy profile diagram, I will have something of this nature. At this point here, I have my reactants. So this will signify reactants. These are reactants. These products. And let's assume we are beginning with zero kilojoule per mole. And then let's take this to be a 5 interval, 5, 10, 15, 20, 25, 30, for instance. Now, considering the structure on the board, the diagram on the board, you can see we have reactants tending to products. Now, for endothermic reaction, this is the rule. Delta H, like we said earlier, is positive. And for us to attain a positive value, it simply means that reading this value here, let's take this value to be 20. It simply means the product, which is delta H, the heat content for product, minus that of the reactant, which is 10. So H arrow should give us a positive value. That means 20 minus 10 will give us a plus 10. That is the only condition for us to have a positive delta H. So H for product minus H for reactant should give us a positive value, which in this case is a positive 10. It's a positive 10. So that makes endothermic reaction to be correct. Delta H is always positive. That means heat is absorbed from the surrounding. Now, taking note of this simply shows an energy profile diagram of an endothermic reaction. Now, how do we identify the activation energy? Now, don't forget, the activation energy is the energy required for collision to exist, for a reaction to exist, for a reaction to take place. The activation energy from reactants down to the top. So we take our activation energy, the energy that is required for a chemical reaction to take place, gives us the activation energy. So this barrier will be hit or exceeded for activation energy to hold. So in this case, we will call this from reactant to the top to be our activation energy, which we use EA. So this represents the activation energy required for a chemical reaction to take place, to occur. So EA is our activation energy. That takes care of this. Now the heat change is HP minus HR, which is our enthalpy of product minus enthalpy of reactant. So enthalpy of product minus enthalpy of reactant simply means this is reactant and this is product. So what we have left is this height. So this is the difference between this and this, reactant and product. You can see reactant from here to here, product from here to here. So this is what we have left when we took the difference, 20 minus 10. So we have this. So in essence, this simply signifies our heat change, which is our delta H. So delta H has been specified here. And then finally, our activated complex. I simply added this. The activated complex is simply the highest point on the energy profile diagram. So this point here is known as the activated complex. This simply shows a simple endothermic energy profile diagram. That is how to draw the energy profile diagram for an endothermic reaction. Don't forget, in endothermic reaction, delta H is positive because heat is absorbed from the environment. I'm sure we got value from this video. In subsequent videos, I shall explain these terms in detail, endothermic and exothermic reaction, for better understanding. And then we see the difference when we compare the energy profile diagram for an exothermic reaction. Please do well to subscribe, like, and share my videos for more persons to see. Have a good time. Bye for now.